Let's see, Michael emailed. We want all those sick people to stay home, right? So I haven't heard from a lot, but a few. Isn't that pretty? Got that. Okay, so we've got our Zoom session going. You guys want to jump in there. Next, I want to remind you to get your OneNote notes open so that you can add to your OneNote notes. Today, we're going to look at that geometric object class project that we copied all that stuff from. Now, we're going to add another object type to it, another class. We're going to create a hexagon class so that you guys can see what we would do to create it from scratch, and then we'll add in the comparison information so that we can meet the requirements of the exercise or the project that you have assigned. You guys will just have to change it up a little bit. Now, some of the people that were in my class last semester, we've done this a little bit. So, you know, turn to them and say, what are we doing? Or actually, they'll just get a chance to try a new geometric object and see how it all works together. But before we get started on that, I wanted to check with you. How's everybody doing with GitHub? Been able to get your GitHub repository set up and a project in it for me to grade? Okay.
So with my previous class I had with us,
I
made different repositories for each
right.
thing. I don't know if you want that.
No, I don't. So make sure you watch that video because I want you to do it the way I want it.
So you just want a link to the folder, basically.
And I want the folder named exactly something. So do make sure you watch through that video. Otherwise, you'll have a lot of redo to do. So if you know how to use GitHub, that's great. But I want you to watch how I want you to do it. And in that video, I'm going to show you how NetBeans will connect directly to GitHub. So if you don't watch that video and you just go off the knowledge you already have, you will be missing some knowledge that you might like to have. So do make sure you watch that. You can fast forward through it. I don't care if you watch it closely. Just make sure you understand that there are lots of differences. Now, in that video, I will make it very clear I want one repo for the whole semester. Your CIS171 repo. Within that repo, then, I'm going to see many folders for all of the different projects that you do. And we want it that way for a lot of reasons. But I'll show you one. You guys might use all sorts of different tools for GitHub. As I'm mentioning, you can actually connect directly from NetBeans. But when I'm grading, I'm going to use GitKraken. I might use something else, but that's what I'm going to start with. So I want to show you how all these repos load that have been sent to me so far, and then you'll see why I am a kind of a bear about the naming, and you'll understand. So when I look at this repo right here, this is one from last year. I'm going to go back to ours for SP19. That's the one I want to open. Open, you silly thing. So when I look at this here in GitKraken, and I'm looking at my folder, when I have cloned all of your repos into my CIS171 folder for grading for this semester, if you guys have them named correctly, notice how nice that's going to be for me. And then I'm just going to be able to click on one of your folders and drill down and see all of your projects and get all to all that information. So that's why I want it this way. Also, it's good for you to see a lot of different ways to set things up. So I just want you to have a little bit of a different way. Creating one repo per project is perfectly valid. And that's a very great way to do GitHub and the way that a lot of people do it. But creating one repo and putting a bunch of projects in it is also perfectly valid. So I want you guys to be able to see from that point of view that maybe you want your whole company only wants to have one repo. That would be weird, but some companies are that way. So that's why I want you guys to name it this way. Now, as I scroll down, you'll be able to see some that weren't named the way I asked, and you can tell they really stand out. And I'm not sure whose it is. When I'm just looking at this, all I can see is that I've got a Gregorian calendar project, but I don't know whose it is. And all of you guys I know will never forget to put your comments in your code, but if this person hadn't, I would have no idea. whose repo this was. So that's why I want them named a certain way. So not necessarily to be a jerk and make you jump through hoops, but I do want you to jump through a few. Yes, sir. Look at it up here. What do you think? Do what?
If we have like one name off, do we go back?
Like yours? Well, think about when I'm grading, Chris. Are you going to be showing up in my gradebook alphabetically by your first name? No. So if your first name is first, you're not going to be in the right order when I'm grading. And I got to tell you guys, when I grade your assignments, I'm going to take it as seriously as you did in creating this project. I'm not just going to fluff through. Well, truth is, by the end of the semester, I might. But I'm going to try really hard not to, because they're all really important. You put a lot of work into them. So for every project I see here, I'm going to create a pull request. And when I create that pull request in GitHub, I'm going to create a markdown file to tell you what I thought of your project. Like, this is great. You know, I'm like that all the time. Like, this is a great job. Did you consider creating another class? It would have been more logical maybe if you would have created another class. I'm going to put those kind of comments in a markdown so that just like if you were working on a project with your project team, they would do a pull request and they would make comments for you. Instead of just sending you a grade then, you're going to be able to bring up that pull request in GitHub and see what comments I made. And then you're going to accept that pull request to complete that maintenance cycle on that project. So you've shown it to me, I've made comments, maybe updated some of your code, like if something wasn't working right, and then posted it back to you. Yes, sir.
Is there a naming convention for the projects inside the repository?
No, and you know, that's a thing. You guys can come up with your own. And I wanted to show you this one because I do think that Nick did a really great job last semester. And so what you'll see if you look at it is down here were his project names. So he just used kind of the same names as they are in Canvas. Like instead of saying project 1, he put number 1 or whatever. And then when I created a pull request, I started saying grade and then whatever the exercise was to try to keep it tied back and clear. So we could definitely use a better naming convention. So I don't have one. You guys use whatever you want internally, and if you come up with a good one, we'll share it and try to get everybody to start doing it. So.
Chapter and project name. It's like chapter 13 challenge.
And so that's how most of them are. But we have a few that aren't from the book that just kind of mess everything up. So we'll see. I think our project number in Canvas should be pretty consistent. But I tell you, I'm just one of those kinds of people that if I'm doing something all in one sitting, I'm really consistent. And then when I come back to it later, I might not be as much so. Now, like I mentioned, this is GitKraken. Nick, as you can see over time, he created some different entries for some different projects. And with looking at GitKraken, he actually put comments in. So anytime he did a commit to GitHub, he made sure to put in a good comment for what he was doing. And then he could just click on any of these and, you know, revert back to that point in time in GitHub and see what his code looked like at that point. Now, to be able to do this, you have to be doing the proper checking in and checking out. Some people I've noticed, and not necessarily you guys, just over the last few semesters, that some people are like uploading a whole project in GitHub instead of doing a check-in. If that's your situation, make sure you watch that video because you really need to be checking these things in, not just uploading the project folder to GitHub. Yes, sir. Commit. Yeah, commit. Sorry. Different terminology in Visual Studio, so slap me every time I do that. Say, yes, that really is another keyword. So if I just upload the whole project to my GitHub folder, I'm not doing any source code control. I have it saved out there. It's on the cloud, right? But I'm not doing any source code control. Anybody else could just download it, change it, whatever. So we want to be to the point where we're doing actual commits and making sure that we're using the facilities of GitHub more than just as a storage container. So do take a second and kind of look through that video, and if you have any questions, let me know, and I'm sure the whole class will want to hear about it, because GitHub is definitely an area where we can just use it in its basic form and not really run into a lot of questions, or we can really expand what we're doing and then have a whole bunch of questions. So
I like that. Added like 3 things.
yeah, he was really specific, huh?
You know what I mean? Was it like 2 or 4?
Probably about 3, but he did pretty good, because it's hard to get good, meaningful comments on those commits. But that's what we really want. So think about this repo here that Nick left behind. If you had your hands on it, he put enough information out here that you would be able to find what you need, wouldn't you? His names might not be an exact standard. We don't have a really good standard. But you would be able to find that program that's due, the calendar or whatever, because he's got a pretty well organized repository. So I am totally all for putting every project in its own repo, but that's just not how we're going to do it in our class. We'll keep everything consistent. So I only use GitHub for you guys for the 171 class. So sometimes if I start reverting to Microsoft terminology, because I have to use it all the time, I have to use TFS every semester for the C# classes. So I get more experience with it. So if I'm using some weird term, ask me, and I might just be using the TFS term instead of the NetBeans term. Now I have a small company. I'm gonna be making a company, I'm kidding here. This is a simulation. Let's say I was gonna start a small company, and I've asked you for some help, and I want to have some applications. I've got a little access database. I want you guys to help me with some code. I want to keep it secret though, because I have these competitors that are really competitive, and they've been kind of like following behind me, trying to steal all my secrets and my ideas as I go. And I don't know if you know anybody that has a small business, but that's fairly common, that other people around are always trying to steal. My husband actually had a carpet cleaning business. So you wouldn't think that people would be wanting to steal his secrets, but they would. So they want to steal his customers. It's pretty strange how cutthroat business can be. So if I say that I'm going to have you write some code for me, but I want it to be stored somewhere in a repository where it's safe, is GitHub a good place?
As long as you make it private. Yeah.
Okay, so we could make it private. So you guys have all made yours private, right? Now remember, there's 2 lines of thought there. One line of thought is everything should be public so that we can all share with the world. That's good. That's a great thought. The other thought is, you guys are students, there could be cheaters, keep your stuff private so they can't get to it. And that's my thought. So I just want to make sure that your code is safe, because I've heard in other areas where people have grabbed people's code off of GitHub. So I want your repo to be private. Plus that gives you an opportunity to work with a private repo and you don't have to worry about it. Now, I agree with you guys that if I set up my repository as private for my small company, it's probably safe. But I want you to understand that a lot of people don't feel that way. And a lot of companies are run by individuals that are very paranoid. That's part of how they got to be so successful. They're always watching out. So there are many company owners who would not be happy with their source code on the cloud, even if it were shared. So that's why we continue to teach people how to use TFS in the C# classes, because that's a repository, a source code control system that can be run on your own in-house servers. So a lot of companies still want that source code in-house on their servers. They don't want it out in GitHub in that shared repo world. So don't be surprised by that. You can work with those people on that if you get a job there, and eventually get them convinced that it's okay. But you probably will run into that a lot where they're not quite as secure with it as you are.
I worked at companies where they weren't connected to the internet.
Right, at all.
At all.
At all, exactly.
And if you were called at 2 o'clock in the morning, you had to get up and drive 60 miles.
To go do your work.
And you wondered why it took you so long to get there.
Yep. So there is still a lot of that. There are companies who have certain computers in certain areas, like that maybe run a system that they paid a lot for, that they will never connect that computer to the internet. So you'll see a lot of things like that where people are really taking measures to safeguard things. And when you know more technically than they do, it's hard for us to not look down on them. We have to try to figure out a way to explain things to them so that they feel more comfortable with it. And eventually they will. But it can be hard when you're like, what? What do you mean you kept that off the internet forever? I used to work with a guy who had a Windows 3.1 system a couple years ago because it ran some automotive cataloging system that he had bought, 15 years ago, and it still ran. So he didn't want anybody to touch it. It still works. So, okay, that's what we'll do. He got new CDs all the time for updates, so that's how he wanted it set up. Last time, we copied in all of this geometric object stuff. Part of what I did was like teach you guys how to pull pieces of code together into a project. You can see it took us a little while, right? Because we copy these Java files in and all these things. And right here, this is why I want all of your projects to be individual folders on GitHub. Because I want to be able to just open your project in NetBeans without having to do a bunch of reassembling. I don't want you to have 5 Java files out there in GitHub and nothing else. I'd like your whole NetBeans project to be out there so I can just open it, use it, test it, look at it. And so that's why we want to make sure that we're getting our whole project folder checked in. So again, that's a difference in philosophy, right? Some organizations might say, just chuck in that .java file. Well, if you need 12 .java files to reassemble this project, it's going to take somebody a while to get it all put back together to try it. So in general, we're going to want the entire project to be saved to GitHub. Now, GitHub is a source code control system, so some pieces of our project will not be out there, the compiled parts. Those won't be checked in to GitHub because they're not source code, so we don't have to worry about them. So let's look at this project that we built, that we put together. I'm going to close all of these tabs here in NetBeans so I can make sure I'm just looking at the ones I want to. I'll even close my start page. And then I'm going to start with a geometric object. Now our geometric object, what did you guys decide? I can Alt wheel to zoom in. Our geometric object class, first of all, is abstract. So in your notes, you might want to put something about abstract. And you guys were showing me all your knowledge last time with Ravel about how great you knew how to set up those abstract methods. By the way, sorry, just a side note, sometimes I'm a little ADHD. We have a couple of students, I don't know if you guys have talked to them, some of you probably have, who are in interview processes for permanent jobs at O'Reilly's. And O'Reilly's is doing a great internship, which is a lot of opportunities for a lot of people that you want to keep your eyes open about for their next interview session, because I think they just ended one not too long ago. But these guys are actually in it for permanent positions. And one came in yesterday to talk, and he was in this class last year. And he said, some of the things they want me to do, he said they have this like automated test system, and they're making all of the interview candidates take this automated test. And so it's not really like test questions. He said it's more like it'll say things like, write the header for the method that does such and such. And I thought, we just did that in Ravel the other day. So Ravel is really good practice for these people, huh? And he said, yes, tell them it's really good practice. So any of those quizzes, projects, things like that that you can do in Ravel, Zach was saying that is exactly what they asked of him in this test, to type those kinds of things out. So we'll try to use those a little bit, but we have a lot of things to do in our class. So anyways, I'm getting back to our abstract class. We saw the keyword abstract comes before the keyword class, and then we have our class name. And when we create an abstract class, we know that it can have no instantiation. We can't make an instance of it because it's too abstract. Now in this geometric object class, we have 3 variables here, class variables, data fields that are part of our geometric object class. We have a string that says what color this object would be. A Boolean that says whether we want this to be filled or not, like with color. And then lastly, the date that it was created. So those are our class level fields. We'll be keeping track of those three things about every geometric object that gets created. Now in our constructors, we actually have two constructors. One constructor, our default constructor, updates the date created with our current date. And then the constructor that accepts the color and the filled status to create a geometric object sets the date and the color and filled values. So pretty standard constructors, pretty straightforward. We have an accessor method to get our color and an accessor method to see if something is filled. Notice it's named just a little bit different. Instead of get filled, it's called is filled. So we'll always see a little bit of differences like that. Now we also have some mutator methods to set our color and set our filled property. We do have an accessor for our date created, but we don't have a mutator because we're not going to let anybody change that. Once that object is created, it's going to stay created. We don't let them update it. We have an override of the system to string.
When you're referring to a mutator, are you referring to something that be either a getter or a setter?
Do what?
When you're referring to a mutator, are you referring to something that be either a getter or a setter?
What mutates?
What mutates?
If you were looking at a getter and a setter, which one would mutate? The setter, right? Because the getter is just going to get it, and the mutator is one that changes it or mutates it. And so that's kind of the Java terminology. Sometimes I have a hard time remembering those, so you can see if I'm getting my setter and can't think of that other word, yell at me. Teenage Mutant Ninja Turtles, and then I can, oh yeah, mutate. That's how I remember everything based on cartoons. So we have our toString method, and then we have these abstract methods that were created. So we could put those in our notes. Abstract methods. What would we want to say about that? They're declared in our base class. They have no body. They must be overridden by the classes, by child classes or inheriting classes, however you want to say that. Where does our abstract keyword come in? We'll put that in. Again, the abstract keyword comes before our return data type. And sorry, I'm writing so small. I just know there's a lot we wanted to fit on there. I know it's hard to see that board sometimes. But that's really kind of in a nutshell what we could say about our abstract class and our abstract method. In the abstract method, you might want to copy one of those and paste into your notes as an example, because that abstract method syntax is the only place in Java we see where we have that semicolon in a method definition, right? Because that just doesn't make any sense. There where we should have our opening, closing curly braces for our body, instead we have a semicolon, because all we're declaring is the header. So then when I override this method in my child class, could I have it return an integer for the get parameter in my override?
You could, but
I couldn't. I said it's a double.
oh, gotcha.
So it has to be a double.
It wouldn't even compile, right?
Oh,
Right, it wouldn't compile. So it won't let us do anything different like that. It won't even let us try it. So whatever we specify here, and if we had any parameter definition within our parentheses, those would have to be the same too. Like a string and a Boolean, we wouldn't be able to change those data types. We could change the names, but not the types. Okay, so that's our base class. We have everything defined there. Looking at the code as you go through, remember the code's super simple, right? It's not hard code. It's not making you think any logical stuff. It's not going to exercise your brain doing any math. It's pretty straightforward when we're declaring a class. Now, what about our rectangle class? This is a child. And right up at the top is where we know that it's a child. So this is the syntax we have to have. Our new class name rectangle extends the base class name. So if I put this here and said this was a derived class, then I can say that I have to use the extends keyword. And that's how I associate this class to its parent class. Now in this class, for a rectangle, they decided that we have to have a couple more properties, a couple more data fields. For a rectangle, we need to know the height and the width. For some other geometric objects, we don't, but for a rectangle, we do. So we've added these two data items to our rectangle class. So now if I instantiate a rectangle, I am going to be setting up the data items for the rectangle, but behind the scenes, it's also going to be creating the data items for that geometric object class. They're both going to be set up and working. Now in our rectangle class, if you look at it, we just have those two data fields. We have our constructors, and then we have a get width, a set width, a get height, and a set height. Because our base class specified that we had to implement a get area and a get perimeter method with those abstract class definitions, we have to have them, and here they are. So we're saying, okay, if you want to get the area of a rectangle, you're going to multiply the width times the height. If you want to get the perimeter, you're going to add the width and the height and multiply it by 2. So
Can you have get perimeter, use get return get area?
Sure.
Times 2.
Sure, if you wanted to, that would be fine. That would be great. So let's look at our circle. Now our circle is not going to be much different, right? It's still a geometric object. It extends, again, that base class, the geometric object class. And the only thing we need to add to figure out the perimeter in the area of a circle is the radius. So we had to have 2 additional fields for a rectangle, but for our circle, we only need the 1. Again, we have our constructors set up, our getters and setters, and then our calculations, get area. So the ones that were required, right, we had to have get area and get perimeter. For a circle, they also created a get diameter because that just makes sense. So even though it wasn't specified as a method that had to be created, they went ahead and created it. It's very helpful. And again, we might need to use this diameter in some other calculation. So we can. Okay, so notice how, again, we don't have any really fancy code. Our classes actually make everything a lot simpler because now instead of a lot of straight through code, things happening, we have each piece separated out to where it exactly needs to be. If we need to make a change, we can go to that precise location and make that change. Let's look at our tester. We have this whole thing built, and then we have a class that's designed as the tester class. So in our tester class, we've created a geometric object that's a circle. And we've created a geometric object that's a rectangle. Notice when we created a circle, we only passed one number because we only need the radius. When we created a rectangle, we passed 2 because we have our height and our width. And then we have some things going on here in our tester. Are these two objects, do they have the same area? We're going to run this equal area method to check the 2 of them. And then we have some things that are going to display our output for us. Now, in this tester, we actually have created this equal area method. This is going to be a lot like the max method that you're supposed to create for your assignment, right? Because in this tester, they've created one that checks to see if they're equal. In your assignment, you're supposed to determine which one is larger. Yes, sir?
Should they have done a line break at the beginning of the second?
Do what?
Should they have done a line break at the beginning of the second statement instead of just adding it in at the third statement? Scroll down.
Doesn't matter. Either way is fine. If you were a programmer, just looking at this code, this is actually the preferred method because those control codes are hidden. And we always want the method that's the most obvious for other people looking at things. So if we're an engineer and we want to use the most cryptic method, then maybe not software. You want to be an engineer then. He was asking if we should have done like a \n in this one instead of having this. And no, we should always have, this is much more easy to see as a programmer coming in looking at this code, right? That I'm going to get a blank line there. If there's a \n in the next one, that could be just embedded in my string. Plus, we don't do console-based programming anyways, so.
But if you want like 2 blank lines, would it be proper to do print line, quote, /n/n?
Yes, because that would be really obvious looking at it. It wouldn't be stuck inside this string somewhere. So they're all fine. We just are always trying to figure out a way to make it easier for the next person coming along to see what's going on. But yeah, luckily we don't do a lot of console-based programming. In this chapter, we're going to start with our graphical stuff where it wouldn't be an issue and we can just do it how we want. So that'll take care of that one. Now we have all of this great stuff. Let's run this thing. And we should see some output from that stuff that was like hard-coded in our tester. We created our circle and our rectangle, and it's showing us the areas and perimeters of each.
Where do they put the values for?
Which one are you looking for?
Well, where do they put the values for object 1?
They're in the top of that test geometric object.
Oh, okay.
You see it?
When that was 5.
Mm-hmm.
The other one's not a 3.
Yeah.
Now we want to, what I'd like to do is create a new type of geometric object because we could change this that's already here, but I don't think it would be as meaningful to us as if we create our own. So let's create a hexagon. So I just brought this up on Wikipedia. I'm not a geometry person, but I can say, oh, I want to create something that's this shape. Well, we only need to create a get area and a get perimeter method for this hexagon. So if I look at this, I see that a hexagon has 6 sides. Basically, they're all the same size. So we're going to use that for our calculation. So we'll just ask the size of a side, one question for one piece of data, and then we'll use that multiplied by 6 to get our perimeter and stuff. And you can yell if I do things wrong geometric wise. So let's start it. First of all, I want to create a brand new class. So in my default package, I'm going to right click and say new Java class. Now let me know if you need this project that we put together last time, because we can send it out via the chat or anything like that. But I want to create a hexagon. Now when I look here, I see I'm getting a warning about using this default package. I'll go ahead and say, yep, that's true, and finish. Okay, so now I have my new class. I want this to be a geometric object. So how do I need to change my class statement to make it inherit from that geometric object class? Extends. Now, as soon as I do that, I get an error. It's like it put my whole class in error. It's got some red fuzzy under it. So let's mouse over that and see what it's complaining about. I'll come over here, my little light bulb. It says that it's not abstract and it doesn't override your abstract methods. So you can see right away how those abstract methods have to be created for us to be able to use this class. So we could create an outline of those right away if we wanted to. Let's go ahead and put in, let's see, we said that they needed to be a double for get area. And right now I'm just putting fake return statements in there so that it will compile. I'm going to go ahead and do the same thing with our get perimeter. And again, I'll just return 0.0 since it's supposed to be a double. Yep, let's do that. Now, if you notice, it gives you a warning about that. So if you look at your little warning light bulb, you'll see it says add at override annotation, but it's just a warning. So what would happen if we didn't add that? It would still work. It would cost more resources, right? Because it would take the Java virtual machine longer to realize that it was an override. So that's why it's recommended. But yeah, it won't cause us too much trouble. And when I put that in, then it's all happy and says, oh yeah, okay, you're overriding that method, perfect. So we've got to come back and fix these. They're not good. So I could put a comment, this is a to-do, and this is a to-do. Some of our project management software actually searches for to-do things in our comments, so we can stick that in there. All right, so great, we've got our hexagon started. Now, I just put these placeholders in, again, so we wouldn't have errors in our class. We didn't have to. We just want to make sure that we could start coding on this without errors causing us trouble. So when I create a new class, the first thing that I want to do is add my class fields. So we want an integer, and this is going to be the size of each side. I guess I'll call it side size. And I want to be kind of consistent with the other classes. So I'm going to look at my circle, make sure that they didn't do anything with any initial values or anything. And they didn't, but they did make it private. So I should do that. Now, when I make something private, nothing else can see it. So even our circle class instance would not be able to see this field in our hexagon class instance.
Just to like verify understanding, if it was public and the circle had a function, it could change that value. Right?
Yes.
Okay.
It could access it and it could change it. And so that's why we want to make these kinds of things private and just allow access through our getters and setters so that we're controlling it. We don't let anybody just randomly change things. Now we've got our variable here set. Looks great. That's all we need for this one. We wanted a couple of constructors and a getter and a setter. I know there's some stuff we can do using NetBeans to get it to generate some code. Can we make that happen? What's she saying? Alt insert?
Yeah.
What's that do?
Pulls up a list of options.
You do getter, setter, constructor, or what?
Did you guys hear? Alt insert. What do we want to generate here? I'd like to generate a constructor first. So let's do a constructor. And with NetBeans, whenever we're generating code here, it gives us a lot of capabilities, and it says you can select which constructor of the superclass you want to be concerned with. So we do care, let's use our default constructor. And what fields do we want to be initialized by this one? Right now I don't want any because I want to have a default constructor, so I'll click generate. Now there would be my default no arg constructor for this class. I want to add a comment. And I'm going to use the special XML comments that are offered with Java. And to enter one of those, you type /*. And when you press enter, it'll automatically be inserted into your code. And if we had any sort of parameters for return values, they would already be specified. And our Java doc uses these type of comments to generate documentation. So let's put something in here. This is our default no arg constructor. And then I want another constructor. This time, I again want to use the default constructor for the parent, the superclass. But this time I do want to allow them to pass in a parameter for that side size. And I'll generate that constructor.
What did you click to generate?
Alt insert.
Yeah, alt insert.
But there's another way. If you go up to the refactor menu, you should be able to do the same type thing. So a couple of different places. Now for this second constructor, again, I want to comment, so I'm going to do /*. When I press enter, notice then how that comment has that parameter already included in it. So I don't have to do anything to document what all is required by this constructor. But I'll put a comment here that and say something like constructor for a hexagon object. So it's hard for us. Sometimes we're doing comments to help us program, and then other times we're trying to do comments a little bit more realistic. Now for our hexagon, we need a getter and a setter, and we could generate those, but let's just type them. It's not that hard. We want to make sure we're getting all this practice. So we're going to say public, because remember our accessor and mutator, getter and setter, are always public. We want other people to be able to access them. Did you break it?
He's got a main in there. Or,
No, I got rid of it.
You got rid of the main?
Yeah.
It's still not generating.
These things need to be in the same project, and they need to be in the same package. So our hexagon is in the PDF package with that GeometricObject. So if you drag it, just install it. And what I did is I selected, I had data element typed in, like inch, side size. You kind of want to have that in there before you generate our field, that.
Oh,
Okay. Okay, he's got it. Let's continue then. We want to have a public int get side size. And in this one, where we're going to return our side size. That's all we need, right? And then our mutator set side size. And for this one, we're going to expect an integer to be passed to us that is the new side size. I'm going to call it value because then I don't get confused with what it is. And I can set our side size equal to that value that was passed to me. Now, changes, what kind of changes should we make? I'm going to look at my circle here again. Get radius, set radius. I think we're being pretty consistent. And I don't think we've gone off too far from what they had for those others. We're saying we only need one side size. We're going to allow people to set it or retrieve it. We have our constructor set up. So now we need to fix our get area and get perimeter. So for our get perimeter, I know what to do. I want to return our side size times 6. And I'll even make it 6.0. So we have 6 sides, so that should give us a good perimeter. Now for our area, it's a little different. Our area calculation for the octagon is actually a little complicated. Let's see what we've got. There it is. Look at all this stuff. So we're going to make it something else ourselves. We're just going to fake in an area. So let's return our side size times 60. And we're just going to make some data come out.
I have a question.
Uh-huh.
So when we were setting the method for the side size,
Uh-huh.
they gave me a syntax, but I typed in return before side size equals value. Is that okay still?
Oh, yeah, if the error went away. Yeah. Sometimes it's just all the time watching you. Okay, so it looks like it's good. Everything is okay here. So I want to go to our tester now and add some information to test our hexagon shape. I'm going to go down to the end after all this stuff that's already in the tester and add our new stuff. So let's add code to create a hexagon. And I'm going to call this hexa 1. And I'm going to say it's a new hexagon. And I'll say this one is 7 for each side. And then I should be able to use this display geometric object and print out information about our hexa 1. Let's make sure that works. I think we might be missing something there. I want you guys to think about what we might be missing that would cause us trouble. So let's run it and see. Down here in my consoles area is the stuff that we got last time. So we should just see a little bit more for our hexagon. And there I did. I got something. The area is 420. The perimeter is 42. So good. 7 times 6. And then I just made that other one up. All right. So great. Everything's great. So that was really good because we saw how easy it is to extend a base class with a new child class. It's super easy. We still have access to all of the things from the base class geometric object. We just added a little bit more to it. Now, the assignment says that we want to be able to, let me find it here, get information for us to compare different instances of geometric objects. So sometimes it's hard when we all come together because it's so hard to know what you did in your Java 1 class, if I'm driving you crazy or not driving you crazy. So pretty soon, I'll know. We'll all be together. But for right now, sometimes I feel like, oh no. Okay, so what we want to do here is add an interface. Whenever we're working with classes, we normally think of having one parent, so we usually only extend one class, but we might need things from many classes to be built together. So an interface sort of lets us do that, where we can pull all of these different classes together. And the example in Ravel is talking about animals. And again, it's a great example. Do make sure you take a look at it. I think you'll really, really like it. But we want to go a little bit further. Come on, silly thing. Won't let me go any further. It's right there where I want. So we're going to use the comparable interface. Now this comparable interface actually does a lot for us, and it uses some things that we haven't talked about yet. So the comparable interface is really small. All it says in it is that if somebody uses this interface called comparable, they have to implement a method called compare to. So this is the whole interface. This is something that comes with Java. We didn't have to create this comparable interface. It comes with Java. We're just going to add it into our program so that we can use it. So the comparable interface says anybody that implements the comparable interface must have a compare to method. Okay? The compare to method is going to allow us to specify how to compare our object types one to another. Which one is greater? And we're going to have that in our code then to say, oh, this object is greater than this other object. Now, the Java system is actually going to be able to use that compare to operator to do things like array sorts of our object, because it will know how to sort them. So we're going to be able to get a lot of benefit out of this besides just putting in a compare to method for us to be able to use to see which is bigger, which shape is bigger than the other shape. So we need to start by implementing our interface. So right here, they give us a little bit of information on how to implement it. When we look at this interface, I said it's really simple, but it does have some code that we haven't necessarily used. Notice this E character inside the greater than, less than symbols. That's called a generic. We'll be looking at generics here in a chapter or two. after our GUI stuff, so we'll know a lot more about it then. For now, just think of it as a placeholder for the data type. So in our case, the data type is going to be hexagon, or it could be a circle or a rectangle. But that E is saying whatever data type we're using, that's a placeholder for it. So let's implement that comparable interface. All I need to do is come up here to the top of my hexagon. And right now, my class says I extend the geometric object. Well, I want to add more and say that I also implement with an S, a comparable. And the comparable that I implement is going to allow comparisons of hexagon objects. So now my class is so much more than it was before. It started out just being this little baby class, but now we can say it extends the geometric object, so it has all of the capabilities and data associated with a geometric object. And then we're adding more, saying it also implements the comparable. So once we get this implemented, it's going to know which geometric objects are bigger than others. How would this matter if we were working with employees? Well, do you want to sort employees by last name? Do you want to sort employees by employee ID? Do you want to sort them by department, by their salary? I could do all of those different things by creating different compare to methods. And I could make all of that happen internally. So by adding the comparable, we're getting all that ability to be able to sort. But right away, it gave me an error. So what's the error I've got?
Not abstract and does not override abstract method compared to.
So now we are getting that abstract method coming from the interface. Still an abstract method, we have to implement it. So let's go implement it. I'm going to go down to the bottom of our code, and I'll do another @override. And we want to implement the compare to. The compare to method expects to return an integer. Now in our compare to, we're going to be working with hexagon objects. And I'll call whatever hexagon object is passed to me O. Now again, I'm going to put in, let me put in my open and closing curly braces and make sure that's okay. Now it's working because even though I said earlier in class that when we implement an abstract method, we have to make the parameters exactly the same as that method definition, we implemented this using a generic, and so I'm being able to put that keyword hexagon there. It'll mean more to you eventually, pull all this together. So now in my compare to method, the compare to method has to be written in a certain way. So whenever we're using a compare to, we're going to be checking to see if the hexagon we're currently working with in our class is bigger than the hexagon that was passed to us as O. So if this hexagon if this one is greater than the one that was passed to me, then I know that this hexagon is bigger than that one. And I can return, oops, I left out my parentheses there. Let's make sure that that's the only thing that's wrong. Now with a compare to, I have to do things in a certain way. So if the comparison is coming out that my current hexagon is greater than the hexagon that was passed to me, I want to return a positive value. Now this is defined by the Java runtime system. Remember, The comparable is part of Java. So it's rules. So if the current one is greater, I'm going to return a positive value. And we can actually get rid of our curly braces in this because they're kind of going to cause a mess. Else if this side size is less than the side size of the one that was passed to us, we want to return a negative value. Otherwise, if they're equal, we're going to return 0. So it's all good, but it says you can't do this because even though you're within the hexagon class, you're going to be looking at another instance of a hexagon, and you said those are private. So you can't just access that variable. So what would I have to do there? How could I get to that size? Yep, I would use my getter.
Yeah, me either.
And it wasn't at first. Isn't it weird? Did I do something weird to it? Is yours okay? I probably got some weird curly brace problem. If you guys aren't having a problem, it's me. Do what? Did I leave a curly somewhere?
If statement's supposed to be in curly braces,
Doesn't matter if you're just doing one thing. Yes, sir?
when you implemented the comparable hexagon, was that curly brace supposed to be here? Because I have a really different error all the way back up at the top.
At the very top? Let's see. What do you have?
Where it's the comparable hexagon, for some reason the line is throwing up an error.
Make sure you have this override that we put in on that compare to.
My override. Yeah,
You're what?
my override.
It's mad at you. So go back up to the top, guys, and make sure you have implements comparable. You're all good?
What it's supposed to be?
Is it just doing weird things? No, I'm getting an error. So you guys, I mean, I shouldn't need those curly braces, but I can put them back in because that is when I started getting an error.
Yeah, I've got curly braces and.
That one's really
Ah, they figured it out for me. Been saying it, I couldn't hear you guys talk loud. I'm deaf as a doornail. Can only hear these people in front of me. Okay, so good job. Now, do I need that? Do I need that getter? Or could I just access that field directly like I was trying to at first? Notice I just have to use that getter because that's a private field and I can't access it directly. So I could change it. There's lots of ways I could do it, right? So on this side of the if statement, I could do get side size also to make them consistent on both sides of the if statement. So we could do it a lot of different ways. The bottom line is we want this comparison to happen. Now, a couple of other things. Curly braces on an if statement. Whenever we're only using one line of code within the if statement, we don't need the curly braces. So remember that because that's always a certification test question because they want you to say, no, you have to always have them. And you should, but you don't have to. But whenever we're doing an else if like this for this compare to, it's just a lot cleaner sometimes without curly braces because it's always this kind of code. It's always an else if comparison. So it's just one of those ones because I'm a curly brace aficionado. I love them. But in this one, it seems like a little bit like I can get away without them. All right, so I've implemented this compare to. What does that mean? Well, that means that we could compare a couple of hexagons to see which one is larger. So let's go to our tester and see if we can make that happen. So in our tester, I'm going to create another hexagon object. We'll make it hex 2. And let's make this one bigger. I'll display it. And this example code here is a really good one for you to step through the debugger. If you want to at home and kind of see exactly what's happening, watch how it's going to the base class when it creates instances of these objects. Now I've got my second geometric object created, so I'm going to use an if statement. And I want to say that if the hexa1 dot compare to using hexa2 and I could say a lot of different things here. If it's greater than 0, then we decided that our first one was bigger, right? Okay, so I'm not being super scientific here. All I'm saying is, for hexa1, I want to run its compare to method, and I want to pass in hexa2 as the thing to compare to. And if the result of that is greater than 0, then I know the first one was bigger, right? So let's run it and see if that comes out right, because we should get that hexa2 is bigger. I hope. There we go, yay. Always happy when it works right. Okay, so now we know that our second hexagon was the bigger hexagon. And our compare to method let us do that, right? Because now we had the facility in place within that class to be able to do a comparison.
Mine worked and I used the O dot side size. I didn't have to do it again.
As long as you didn't make it a hexagon. Used O. Oh, did you make it a hexagon? Or you still didn't have to? Yeah, you shouldn't have to. It's being weird.
Yeah.
So I don't think you would have to. Good. So try some different things like that. Some of it is NetBeans, which is always fun. So this is great. I can now tell which object is bigger than the other. But what if I want to create an array of all of these hexagons instead, and then I want to be able to use them in my array? Let's create an array of hexagons. Hexagon, X, array. Oh, I want to make it an array. So I want my square brackets. And I'm going to call it hex array. And I'll say that it's going to be a new array of hexagons, and we'll just make it like 4. We don't need very many. Now this first hexagon that I created, hexa1, I'm going to change it to be hex ARR 0. Why am I getting that error? It says variable hex ARR is already defined. Well, I know it's already defined. Why won't it let me? Can you tell what's wrong? Right, anytime I specify the data type, I'm saying that I want to create that variable. And I've already created that variable. Okay, so there's my first one. I'm going to change the output then to use hex ARR sub 0. Then this next one, I'm going to create a new entry in our array. So hex ARR 1 will be our hexagon that's the size of 9. And then we'll print it. Finally, I'm going to change my if statement to use the ones from the array. So if I run this now, I should get exactly the same results, right? It should be totally invisible that we changed this to an array holding these hexagons. We should still have the second one bigger. Shouldn't matter that I'm looking at an array. So let's just run it just to make sure we don't mess anything up. Good, it still says hexa 2 is bigger. So that's what I wanted. So great. Now, I would like to add a few more. I'm going to set up, and I just have this hard-coded because I just want you guys to see how we can sort all this stuff. I'll create another one that's a size 3. And another one that is, I don't know, 6. They're all different then. As I go through here and I'm adding in code to print these things out, I don't want to keep doing all of this hard coding of each entry. Can I use some sort of for next loop or something for each loop to print all those out? So my syntax is for, then what? Now I want to do a for each.
Yeah, so it's open trim,
Okay?
and then your variable type.
So for each hexagon in hex array, is that right?
So do you like a variable name?
Yeah. We'll call it 1. So for each of those then, we could do our display geometric object. And we'd want to display that one. So now I'm going to get rid of some of this extra stuff. So stay with me. I'm going to get rid of the if statement we added and these display geometric object statements up here, so that all we have now is create our array of hexagons, add 1, 2, 3, 4 hexagons into our array, and then our for each loop should print each of those out. So let's see if that works. So sure enough, I'm down at the bottom. I see our 420, 540, 180, 360. That's looking good. So let me leave that up there so you can make sure you've got it. Now we already added our stuff. So whenever we were working with our, where's my hexagon? There it is. With our hexagon, we already added in this information about how it implements the comparable. So if we try to sort our array, it's going to work. What I'd like to do is show you how it wouldn't if we hadn't added this. So you keep yours just the way it is. And let me make this small change real quick. I'm going to put my opening curly brace here and comment out my implements. Now in my tester, if I try to sort my hex array, Ugh. Where's it gone? Let me find it.
I think the book went like all the way and was like Java dot.
Is that what I need? Because I don't have enough stuff. That's it.
You know, to import it. And then something about lane.
Yeah, we could import it. It would be a lot easier, huh? But we'll just try to. There it is. He's got me. And what I want to sort is our hex array. Now I'm going to try to run this. You don't have to, like I said, because we're going to add this in. But I want you to see what happens if I don't implement that comparable. Let me cancel. Saying you have errors. So I'm going to cancel, and let me find those. They're in our hex Java. I did something that it doesn't like. I probably can't comment that out the way I wanted to.
You still have your override statement.
Yeah, that's why it's wrong. Mad at me. Okay, let's see if we can run it then. So I want to try to sort this array. That's my whole purpose here. And when I get to my statement that does the sort, it says, you know, you wanted me to sort this hexagon, but I don't know how to use it as a comparable. So it even says the word comparable in our error message. Like, you have not told me how to compare these object types, so I don't know how to sort it. So now if I go back to my hexagon and I put all that back so that it's like yours, make sure I have no errors, and I should be able to run, and this time without changing my sort code. So let's go ahead and put this in, and yes, we could use the import to get to the right place. But we're saying a arrays sort method in Java. I would like you to sort this hex array. So let's do it. If I run it now, I should see that I don't get any error, but I'd like to see that sorted output. So I could just copy our for each loop and run it again after I sort the array. And now I should be able to output that sorted version, and we should see them in order. So when we're learning to program, this comparable interface is kind of abstract, kind of like an abstract class. It's sort of hard to wrap our heads around it. But what we're doing here is saying, I want to take advantage of the Java runtime system and its ability to sort objects. And I want to take advantage of that. So I'm going to implement the comparable interface. And when I implement the comparable interface, I see, oh, you have to make a compare to method. And the rules are, whatever you're comparing to, you're going to give me back a positive number if this item compares to higher than it, a negative number if it's lower, and 0 if they're equal. So it doesn't matter what I'm comparing. I could be comparing, you know, race cars or mileages between things or anything. I can use this compare to method in my code, and then I decide what field actually decides what the sort is. Does that make sense? So it's kind of out there. That's done a great job. Let's save this. Now, your assignment says implement the comparable interface. That's what we just did. But you're supposed to implement the comparable interface at the geometric object level. So you're going to take what we did down in our hexagon level and move it up to the parent class. So you're going to be putting that compare to method in that parent class instead of down inside your circle or your rectangle. You should be able to figure out how to do that. But it shouldn't be too bad because you've really got all of the pieces. It's getting all those pieces put together, I know. So questions about this one before we close it? Now, I don't have a GitHub repo open or anything here, but if I did, I could push it, right? And then I would have it when I got home, and I wouldn't have to worry because it would all be there. So for next time, we'll try to create our project in a GitHub repo folder so that we can just push it.
Can you put that back up there?
Sure.
That thing brought me to the point where I couldn't keep up.
Well, that's why we video it. Just remember, what I've seen over the years is, if you can't keep up, we would rather help you get there than leave you behind, so let me know. And a lot of people, you know, you might want to sit over here by Justin. He's got some room.
I'd rather you stay over here.
Yeah, I want your help there. But no matter what, yell at me, you guys, because I got to tell you, my class is super boring if you're not following along with the code. That's just how it works, because we're hands-on. If you don't have your hands on, you're going to get bored and wish you had your hands on something else. Yes, guys?
I understood what you were talking.
Are we in the process today?
Do what? Yes, we need to do that.
0903, that's the one.
I got a question about the assignment.
Uh-huh.
So does a lot have to change within like the smaller classes?
No, it's very
It's just-
minimal. Yeah, you probably won't change anything much within those smaller ones. Yeah. So it's so weird because the concept is so difficult. The code is really not.
I'm still like,
It's the concept. Ah. So what we use interfaces for, just like Java, they say if you want to sort, you better do it this way. And we might do that at work and say, I'm going to create these interfaces so that everybody codes all the same. You guys ready for a field trip?
Oh, gotta go.
You wanna take it?
what I did was create my batch.
You know what it is?
I think I should be able to figure it out.
It's cute.
Unfortunately, I'm gonna have to send the individual
I'm glad
class
she's
to,
doing that picture.
it's gonna be the
No, no,
individual
go to
class.
my office. Somebody did. Oh, Jim does. Jim, come be in charge.
Why do I need to be in charge? Give me just a second.
You did C. Everybody's gonna follow you.
But I can send all of those ones.
He'll find it. He's not coming.
The test one is the one you get in class.
Right.
So this one that I've got here.
Oh,
I opened it up that way in packages, so I have to keep it for that. Copy this one. So just be mindful of that. You could open up a new project and just put them in one by one. Yeah. Or whatever you need to do.
But you
But
do
yeah,
it just like I'll make a folder.
Do you have anything else?
So like,
No, you don't.
like create a file, it'll say
No
name your
way.
file and you just do name of folder. And then you hit the file.
Oh,
No way.
I got some movement to do.
Okay, guys, come on. I'm gonna go upstairs, find this sheet of paper because this is on the tonight. Now come back, because we still want to look at what we're gonna do next time. I'm not letting you off the hook yet. We were behind here on this stuff that we did so far.
So we are coming back.
You are coming back. Leave your stuff here, follow Jim, go sign that so we can get everybody's. This one is Jim's, and you'll see the.
23.
Yeah, I think you'll see the piece of the paper stuck up there. That everybody signed, that has been taken care of. I'm just gonna stay here and guard your stuff. Read this nasty email that I got.
don't know how I made it back.
You got here though, that's all that matters. Thank you, sir.
Yep.
Wrangle this group. We're missing some. They're going to miss their opportunity for easy points today. Okay, Java FX. You guys might want to start a new tab in your OneNote. Chapter 14. Chapter 14 here. Now I know when you guys do this intro presentation, you're working really hard to think of something you want to learn for that question of what you want to learn, because I know you just had to take the class. And a lot of people said they want to do GUI stuff, so we finally get a chance. Whenever we are working with C#, we usually use GUI to start doing GUI stuff first semester. Java, until the advanced class. What's that tell you? It's a little harder. It's not quite as easy as it is with the Visual Studio interfaces. So what about Java GUIs? Why is it harder? Well, we have to do a lot more coding than in some other languages, but it's all right. It's not that bad. Some of you guys that are web devs, it's going to seem like a piece of cake to you. I need to take those classes so it would be that way for me, but right now it's not. Now, the old Java stuff used the Abstract Windows Toolkit, or Swing. So you'll see that a lot. People will talk about Java GUIs and they'll say, well, it's Swing, like that's the only alternative. Well, it's not the only alternative. And actually, the Abstract Windows Toolkit in Swing components have been retired for a while. A lot of places use them now, a lot of use. So you're still going to run into them all over the place. So it's not like it's something that you won't ever see. But be aware, there's the old style Java GUI, which is AWT and Swing. And then there's the new style. And we're going to be learning the new style, right? Because we don't like to teach you guys things that are obsolete, even if they're used all over the place. So this is one of those hard areas where there's a change going on. So whenever we're using Java FX, the new way of doing graphical stuff with Java, we're going to be using at least these libraries. So we'll have imports in for all of these different utilities. Notice that they don't start with Java. So this Java FX component that does graphical stuff is so important. It's like considered a whole nother set of libraries, all of the Java FX libraries. When we're working with Java FX, We're going to be talking about the different components we have, but you're going to see how it just really lends itself to inheritance, and you guys being able to extend the classes that are available in these class libraries to make them do what you want. So we have a lot of different libraries that we'll be using. Some of our programs that we do together, we'll type all of the import statements at first so that we get used to it and really start thinking about all of these libraries that we're using, and then we'll start copying and pasting. You'll see also that we can't just do .star on some of these, that it won't find things properly because of the way they were compiled, and also they're huge. So we can end up with way too much stuff if we just import the whole, for example, scene library. So we'll do specific things. So whenever we're working with Java FX, the whole world is a stage, and that's how we start, your primary stage. So when you create an application and you want to have something display on the screen, whatever you display is going to be controlled or placed on your primary stage. So your stage is kind of like your viewing area. So the stage holds the scene, right? So in this case, he's doing something, but he's the scene that's going on, right? We're watching him, but he's on that stage. If that stage wasn't there, he wouldn't be there, so the stage is super important. So whenever we are working with Java FX, the stage is a primary component. It doesn't change. On the stage, we can show different scenes. Just like our TV at home, the TV being our stage, the TV itself doesn't change, but the scenes that are being displayed upon it change, and we see all of the different stuff we want. That's how Java FX is. The stage is sitting there, and we can display whatever scene we want to upon that stage. Whenever we're working with creating a scene, our scene is going to be our container, right? It's going to contain all the stuff that we want to display. Within that scene, we're going to have nodes. Nodes could be things like text boxes or buttons or maybe labels. But any sort of thing that we would see displayed on a screen is going to become a node for us. So everything like text boxes, buttons, etc., are going to become nodes on our screen. The root node is going to be the node that contains all of the other nodes. Each node then could become a parent if it has child nodes. So looking at this layout here, this root node contains all of these things. This could be a text box and a text box. They're individual, they're just in part of the root node. But down here then, I've created another little container, and maybe I have an OK and cancel button or something in there. And so that becomes a parent node. So it's all very dynamic, very flexible, constantly changing depending on how you want things to display. So you have all of the capabilities in the world to do things. So we have all sorts of different types of objects when we're working with Java FX. Our base level objects, the nodes that we're used to seeing on forms, checkboxes, radio buttons, maybe like a rectangle or a slider or a regular button or text, all of these things. So this picture is just showing you that your root node is probably a pane, because the pane objects usually can hold other objects. You can think of them as a window pane. So our root node is going to be the whole screen, and then each pane can contain additional things. So I could have a stack pane, I could use a border pane, I could use an H box or a V box or a group to become a parent. So lots of flexibility. Let's look at some pictures. Here's one. This scene has the stage, one of them, and it has one scene. Then within that scene, it has some sort of control that is a parent that has other nodes. Yes, sir? That what?
A program that has been made with Java FX.
I wouldn't know. When you look at Canvas, Is it Java? Huh? JavaScript on Canvas? I don't know.
The easy way to find out.
I can see.
Mine said it was a WordPress website, so that's not the
Canvas?
yeah. That's what I hear. So
I don't think it's a WordPress website.
it looks very,
It looks very Java-y, doesn't it? I don't know if it is, but that's kind of how we would be able to tell if something was JavaFX. We shouldn't really be able to tell unless we'd heard of a lot of problems with it and we knew.
Inspect element.
What?
I did this.
Uh-huh. Yeah, but this isn't Canvas. That's OTC's My OTC.
Right.
So you have to go into Canvas. And I don't think Canvas, but it could be, you know, there's lots of different things. So no, you would have to do some research about JavaFX and see what you can find. Now, whenever we're looking at software like that, that's true. A lot of times we don't know how it was created. We don't care as long as it's working. But when it's not working, we start caring a lot. One thing about JavaFX is it's very XAML-based, XAML. So it's very similar to web stuff and new Visual Studio stuff. So you guys are going to like it because it's kind of like the newest standard for GUI design. So you'll like it. So here's a stack pane. In this stack pane, you can kind of think of a pane as being really flexible. It moves around a whole lot. So a stack pane says, I'm going to start out just this little teeny area. And as you add things to me, I'm just going to stack them. So I'm just going to create a stack of things. So in this stack pane, we said create this stack pane, add this label, add a button, add a button, add a button, add a button, add this checkbox. And the pane just took care of it and said, oh, I'm a stack pane, so I'm going to stack those things in a column. And it took care of making it look this way. It lined it all up, and it was like, oh, okay, I'm a stack pane. I can stack all this up. Now, a border pane, a little different. With a border pane, I can specify more information when I add things to the pane. So I could say, I want this thing to go in the center. And I want my cancel and OK buttons to go at the bottom. So in the border pane, I have 5 areas of the window, and I can specify which area of the window a node goes into, my buttons and things like that. A grid pane, you know you've seen these ones. A grid pane gives us a whole bunch of different cells. So it just kind of separates the whole windowed area into a series of rows and columns. Whenever we're looking at a grid pane, again, we can specify, if I want to add a button into this pane, I could specify which grid position it went in. And I would do it just like an array. This would be position 0, 0, 0, 1, 0, 2, etc. So each of those grid locations has their own number, unique identifier, so we can add things to it. So the grid pane is probably used quite a bit. So here's a summary of a lot of the different pane types that are available in JavaFX. So the VBox is just saying, it's not a pane, it is a container. So with a VBox, I'm saying, I'm just going to organize things just like a stack pane. They're going to be stacked in a vertical stack. An HBox is the same thing, only it's horizontal. It's like, oh, I'm going to put all of these things side by side within this pane. Here's a tile pane, which is just a lot like that one we looked at. You can tell there's so many different ones. This anchor pane gives us a lot of capabilities because we can actually say, I need an area over here and an area over there and an area over there. So as you play with them, you're going to see there's a lot of different ways that things are going to come out. And if you've ever seen a user interface that didn't quite work well, it might be because they used a pane and they didn't worry too much about things not fitting. Now, one thing about this is because we're using these panes, they're dynamic, right? So if I start out displaying a Java screen on these monitors that are huge, and I take up the whole screen, Java's going to decide how to use up all that space. And it's going to organize everything based on the different controls that have been placed in that GUI stage. Now, if I go to a small display, like on my phone or something, again, Java's just going to try to figure out how to best organize all of those pieces so they'll fit on that small pane. So it's very dynamic. It's going to resize based on our window size. If we look at a C# program that uses Windows forms, it's going to have a much prettier way to develop the forms, but it's not going to give us that dynamic capability of resizing. Our XAML forms give us that capability. So that's what we're going to be looking at next time. We'll get started creating our first one. Your first assignment is going to be to create a GUI that's all about you. So I want you to think about how you could do it, kind of like I asked you to create a PowerPoint, but this time I want you to create like a GUI application. So it's pictures, do different things, try to use as many different controls as you can about you. And then we're going to stop there. I don't want to go into that one. We'll stop there. All right, because we're about out of time, and you guys have done so great. Questions?
So what does this actually do tonight? The assignment that we talked about.
Your calendar assignment is due. If you look in Canvas, you should be able to check.
Yeah, I saw that. That was due. But
Mm-hmm.
I was just making sure geometric assignment was due tonight as well.
No, I moved it to next week. So yeah, if you look at your calendar, you should see that one. But if you've got it done, get it out of your way. But no, you guys need more time on that one. So in our syllabus screen on Canvas, if I go to it, I'm looking at the wrong class. Let me find our class. I'm just looking at assignments. Make sure that due date is changed. So you guys can see why I try to not change them. It gets so messy. Yeah, your geometric object isn't due until next Tuesday. There is a quiz due tonight. Thank you.
Do you have an assignment on random 0 or 1?
That'll be due on the 5th also.
14.7.
Mhm.
When I looked it up, it's just showing colors. It's not showing anything with numbers.
I'll check it because they might have changed it.
Yeah.
Because I haven't looked at it in the book. I'll check it. Thanks.
And is there an example of this GUI project we're doing that we can just look at?
About you?
Yeah.
Nope. You just have to figure. So we'll do some examples next time. So you can look at the videos and stuff that create some GUI projects and get an idea. So it'll just be display. You don't need it to do anything. You have a lot on the 5th because we put this other one off, but it won't be hard. Yes, it'd be better if it was. It's up to you.
Why does the assignment say it's available till like the 29th? Due on the 5th? What do you mean available?
The available dates are like messed up, so let me know if you see those. I'm trying to get them fixed, but I haven't had a chance. It should be the same, and for some reason Canvas didn't do that when it copied, and it normally does that. It's just trying to make me look bad to you guys. But yeah, it should be that.
Because it was saying.
Oh, okay.
I had set up a student account that let me do a private repository.
As long as you can do a private
Okay,
repository.
great.
We just changed that the week before the semester started. So you guys don't even need that student access now since they made that change. So you're fine.
So other than the quiz, there's nothing tonight?